I changed the title of my slide, as some may notice. I realized that I think we need to have a little talk about unified task parallelism before we talk about applications of distributed task parallelism. So I'm the maintainer of Dagger.jl, as many of you probably know. And I have kind of a bold vision that I'd like to talk to you about. So what is this vision? So what if every function in Julia you called was parallel and scalable? This is bold, I know. Just go with me. What if every function you called was ready to run on GPUs, any kind of GPU? What if every function you called adapted itself to your hardware? Say it's parallel scalable beyond just a single device, and it knows the GPUs you have, it knows the CPUs you have, it optimizes itself. What if you didn't have to rewrite your code again and again and again for, different hardware setups? Users have different setups. And we want our code to work great everywhere. And what if this library already exists in Julia? So my assertion is that's Dagger. It's bold, I know. We're, as this says, building a scalable, heterogeneous computing library that has all the APIs that users and package authors need, with a sensible and consistent design that all builds on a simple task API. So I'm going to do a quick show of hands. Who here has implemented an algorithm that uses multi-threading successfully? Okay, thank you. Same question for distributed computing, multiprocessing. Show of hands. Okay, and for GPUs? All right. How about all three at the same time, successfully? Okay. I was hoping for this. So, the assertion I'm making today, doing that, combining the three of those is easy with Dagger. Not really something that we've been able to do before. I have some code examples up here. Don't read into them too much, but we have the key point is we have a variety of APIs in Dagger that basically can do this. We have tasks, the basis of everything in Dagger, but we also have things like arrays, where we have our D array with distributed multi-threaded GPU operation for just basic simple stuff, matrix multiplies, broadcast, all that. Automatically handles all three of those modalities. We have DataDeps, this new thing that's kind of come out in the last year that allows really powerful, scalable programming in Dagger. And also this new thing I'm working on, SPMD, kind of like MPI or CUDA, again, kind of looking towards this really heterogeneous scalable parallelism. So I wasn't prepared for the animations. Okay, so Dagger meets you at your problem. So unlike, some libraries, you may have to, with other libraries, you may have to fit your problem to match the library, right? I'm sure we're all familiar with this. It's like, oh, I have a nice algorithm. It's sequential. I want to parallelize it. Ooh, now I have to tear my entire algorithm apart just to make it work. I will just read them. Thank you for telling me that. The thing cut off at the bottom under acceleration is multi-threading, multiprocessing, and GPUs. Thank you. So basically, the point is that Dagger meets you at your problem with APIs that are generic and sensible and you already use. Arrays, tables, graphs, supporting also kind of new stuff that still is very simple to work with, streaming and SPMD coming soon. And as I said, the three main modalities supporting all of these. Any API that Dagger has basically supports the three, and if they don't, file an issue. We should fix it. Additionally, Dagger knows your hardware. So you may not know your hardware. You may know your hardware. Dagger is already aware of it when you say using Dagger. It knows about Julia workers, CPU threads, GPU devices of any kind, the various memory spaces that they all have, and any disk devices, the storage you have available. Additionally, Dagger measures a lot of really interesting stuff, like the execution time of the tasks you submit, the number of allocations they make, network transfer time, data locality. Obviously, you can't see those down there. Why? Because it wants to optimize the algorithms that you submit to Dagger. It wants to optimize the crap out of them. It wants to make everything run as fast as possible, and to do that, it needs to know everything about your system and everything about the problem that you're giving to Dagger. And additionally, Dagger is pretty convenient. We, in particular, have a lot of really useful features. A built-in dynamic, also heterogeneous scheduler, work-stealing load balancer, automatic data movement. All three of these automatically enabled by default. You don't have to do anything. And then out-of-core and checkpointing when your problem starts getting really big and you need to be able to work with data that just doesn't fit in memory or doesn't fit in VRAM. Lazy file loading if you have a ton of files or big files and you only want to load stuff in on demand as necessary. Fault tolerance if distributed.jl decides it's just going to give up and go home. That's okay. Dagger will handle that just fine. And additionally, logging and visualization so that you can make pretty plots about the wonderful scalable performance of your algorithms. And if you saw the workshop, you may have seen some of these. So why not some other parallelism package that exists in the Julia ecosystem? So real quick, time check. So most packages, not just parallelism-specific packages, but most packages try to solve their own problems, right? Domain-specific stuff. I don't know, maybe you have an ODE solver library, and it rolls its own multi-threading, it rolls its own distributed GPU, all that, and that's okay. But it doesn't necessarily compose. In many ways, it may not compose in terms of Julia's generic APIs. It may not compose in terms of performance. You may have an ODE solver, but you may also have a machine learning model in there. And do the two know about each other? Do the two operate efficiently together? Often not always. And what also happens is that the domain specifics that those packages handle and the parallelism that they implement become non-separable. And so you can't actually necessarily reuse that parallelism. And of course, you can't necessarily as easily build features into that parallelism like the ones that Dagger has available. So basically, we end up with many different infrastructure solutions for parallelism, and we re-implement the same algorithms again and again. Sometimes they're reusable, but sometimes they're not. Even though that's kind of the goal of Julia's, write an algorithm once and it's generic and reuse it, but that's not always possible when it comes to parallelism. So for reference, users here, when I say users, that's all of us. That includes me too. That includes package authors. That's a generic term for everyone here today. We all get confused when we're deciding, what package am I going to use to parallelize a given problem? There's a lot out there. I mean, even for me, when I'm developing Dagger and I'm adding some new modality, sometimes I'm like, actually, what should I use? Do I need to roll my own, or do I need to grab something that's out there? Can we settle on a single foundation? I mean, I know it's a big, bold statement to say, hey, maybe we should just kind of pick one thing. Maybe we can. Maybe it's a good idea. Now, and again, my suggestion is that Dagger is that one foundation. Now, there are some barriers to this. We have, so just quick overview of what we have. Let's go one by one. So in terms of overhead and memory usage, so if you were at the workshop on Tuesday, you're aware of this, and you may have heard little bits about this from me if you've spoken to me as well. Dagger has overhead, always is going to have overhead. Any abstraction you use will have overhead, but most of this is incidental. I mean, 95%, I would assert that probably 95% of the overhead in Dagger today can be removed with the application of some basic software engineering skills. The reason why there's this overhead, when you make decisions like using dynamic dispatch within your scheduler for good reasons, Julia's compiler can't help you as much, so you got to do things like caching and memoization and all that stuff you're on your own. And I'm doing that now. If anyone wants to help, if anyone feels like that would be fun, please message me. Missing algorithms. So, of course, if you're going to use a parallel computing library, you need algorithms that work on top of that actually solve your problems. Linear algebra, MapReduce, broadcasting, slicing, indexing, whatever you need, those need to be available, right? And, of course, we need to write those, but we need people who know how to write these. I mean, I can tell you how Dagger's APIs work, but I can't tell you how to implement I can tell you how to do Cholesky, but I don't know how to do LU. I don't know how to do SVD. I need people like you, people in our ecosystem, to implement these. So we need more contributors who know how to do this. And, I can guide you on how these APIs work. They're somewhat documented. We're going to talk about that momentarily, but, we need people who are willing to do this. Now, the barrier to that is documentation. If we're going to have a universal API, a single foundation, it needs to be well documented so that I'm not the bottleneck for telling people, how do you use Dagger? You should be able to go to the documentation and see, oh, okay, this is how all of this works. Our documentation is lacking. Our examples are lacking. And again, I would love help with this. We want to make Dagger into something where it can scale not just to hardware and software, but also to the contributors and to the people who want to use it and develop it and improve it. And, if you don't have this, users are like, I don't know how this works. I'm going to use something else that's documented. So, and that's unfortunate, and that's something we can fix quite easily. And finally, consensus. So I made this big, bold statement. I know probably a lot of people are in the room are thinking, I don't know. I don't know if I'm willing to commit to Dagger. That's understandable, but I think we need to have a discussion about maybe starting to centralize on something, whether it's Dagger, whether it's something that might look similar, somewhat different to Dagger. We should start finding something that we can all build on, because if we're re-implementing the same stuff again and again, and, this package works with these kinds of acceleration, but not these other ones, and this one is got a different set, and they're just not performance composing together. I mean, we can't write scalable code easily. We have to resort to rolling our own everything, just like they do in all those other languages. I won't mention them. And this is the end of my talk. I would say if anyone wants to discuss this, I'm leaving a lot of time for discussion. I would be happy to discuss this, positive, negative. I'm really interested to hear what people think. So that's it. Please give Dagger a try if you haven't already. If you have in the past and have been unhappy with it, give it a try again and reach out if you run into trouble. And of course, contributions are always welcome. Thank you so much for listening.
Great, thanks a lot. And we have quite some time for questions.
So, thanks. Dagger's pretty cool. I know of other projects that have parallel task tuning heuristics, like Futhark. Really cool small language. But it's based on a more restricted language, and then they can compose it and make all sorts of interesting proofs for the compiler to specialize on because it's built on Haskell. Mm-hmm. Are there any big semantic or type theory barriers in Julia that would prevent Dagger from being way cooler, way more powerful that you know of?
Yeah, that's a great question. So I think that there's a few areas where the answer to this could be yes. I think for the most part we don't actually have too many problems with this, and the reason why I think that's true is that we have a lot of very powerful reflection capabilities, the ability to take a block of code, add a macro in front of it. You can see the AST, but you can also dive down and start seeing all of the internal IR, all of the LVM, all of that. So if you want to go and do really cool optimizations with Julia, we have the tools to do this. So there's no reason that what I've talked about here today couldn't also be something that is more generally applied as kind of like, maybe a compiler optimization or something like that to automatically scale code without even having to deal with Dagger-specific APIs. I assume this is kind of maybe what you're asking is like, can we have this just for big blocks of code, just say, make this fast? You know, I think something like that is definitely possible. Yep. Thank you.
Any other questions?
So one of the things that have made me hesitant so far to use Dagger as a primary processing framework was that the load time is quite high. So depending on Dagger currently has a high impact, but the thing is you cannot, if you have an extension, then you again have to have an execution mode, and then you have to say, oh, if execution mode and Dagger is loaded. So can this be done on a medium to short time frame that we get the load time to, let's say, like, I don't know, 10 milliseconds or something that package authors will really say, yeah, I can take this on, because otherwise we have this chicken and egg problem. Oh, it's a heavy package, I don't take it on, but nobody's using Dagger. So is there a path to at least have a lightweight core of it or something that we can depend on?
Yeah, and that's great. That's actually a barrier to adoption that I really wanted to talk about. And I've had a little bit of discussion about that today. Yes, like package authors especially are not going to want to adopt something where they're kind of hamstrung, they're stuck with just one approach, and if that approach falls short of its goals, which happens, they don't want to be stuck. It's my belief that the generic APIs that Julia provides to us can somewhat solve this issue. I mean, let's talk about, arrays. I mean, if you're not happy with Dagger's D array, just switch to a different kind of array. I mean, if you write generic array code, this is totally possible. Similarly true for a variety of things. Data depths in particular, I'd like to mention, though, because that's one of the big things that we've been developing this year. That's something, in talks with Sergio up here in the front, we're considering that, hey, maybe we should add a more generic version of this API, which is quite powerful. Maybe we need to add a very small base package that just implements the API, but also have backends not just for Dagger, but also for sequential execution, for debugging, or if you want sequential execution, quite easy, naturally transforms into that, but also multi-threaded, potentially also just distributed or just GPU. No reason we can't do that. I'm honestly very interested in that, because that is a big barrier to adoption. Anywhere else where that's the case, if you find that when you're looking at Dagger, please report that and suggest that. Like, I'm very open to having interfaces which are not Dagger specific, but can be powered by Dagger when Dagger is loaded. Yeah, thank you.
Any other questions?
Thanks for the talk. 2 questions. First question is short. Is the scheduler NUMA aware? And second question, how much of the dynamic scheduler can I turn off and switch to static scheduling? So basically analyze my hardware up front and then, run statically. Yeah, great questions. Thank you. So the first question about NUMA awareness. So Dagger is not currently NUMA aware. And that will lead to reduced performance if we end up ping-ponging memory between NUMA domains, which obviously we don't want to do. So what I've been working on very heavily, and I have it's basically a local development branch, is an entire overhaul of the scheduler, not an entire overhaul, an addition of programmability to the scheduler. Because right now, all of the logic of the scheduler is pretty hard-coded. On this branch, I'm basically switching to a more programmable, more flexible system, and in that system, we could quite easily define NUMA awareness as part of the overall cost function that Dagger's scheduler computes. So and the idea would be that we add an implementation of NUMA awareness. We say, okay, thread 1 and thread 2 are not exactly identical like Dagger tends to treat them, but actually what NUMA domains are they on, especially considering thread pinning. Where is a thread pinned to? Okay, now we can say what NUMA domain is that, and actually add that awareness. And then to get to your second question, Dagger's default scheduler is dynamic, but the data depth scheduler is static. And so if you use data depths, which I highly recommend for writing algorithms, you get static scheduling, and Shemek up here in the front has been working with me on a very powerful new scheduler that we're planning to integrate
that uses a proper optimization model to do full-on static scheduling. So definitely be on the lookout for that. Thank you.
Now maybe a last question while the next speaker can start setting up everything.
Maybe a related question. I assume as the system gets big, the single central scheduler will at some point become a bottleneck.
Yes.
Is there a path to a system where we have like sub-schedulers for sub-parts of the graph that say, okay, now this scheduler first will schedule locally, but if the node is really overloaded, then it'll pass the work back to a higher level scheduler to go to some entire other.
Yes. This is also something I have a development branch for. Again, I don't like to merge development branches that are kind of not yet ready to go, so I've got a lot of features that are in progress, but that is definitely one. Notably, the first part is distributing the scheduler so that the scheduler runs on each worker rather than just worker one. I already have that working, I just need to get that ready to go. And that will alleviate a portion of the problem. Also, work stealing and work sharing across workers will also assist with that and reduce those bottlenecks. Sub-schedulers, we should talk about that in more detail. That is definitely something that I've thought about and I think could be quite powerful, especially considering the new programmable scheduler framework I'm working on. And so, yeah, that would be a possibility. And basically could be something you could just implement and plug right in. But if it works out well generically, we could just add it to Dagger. Thank
Great.
you.
Thank you very much. And thanks to the speaker again. It's time for our next talk.